Hello everyone. Now we will continue the same class. That is, we'll continue the same topic, that is inverse circular function. Okay. So this section carries 4 marks. Okay. And this is from page number 98. Same exercise is there. I think it's exercise 4 and page number 98. Let us prove that. Okay. So let us prove that. Question number 23. Sine, cosec inverse, cot, tan inverse x is equal to x. So you should prove LHS is equal to RHS here, right? So LHS is equal to sine, cosec inverse, cot, within bracket, tan inverse x. Okay? So now how will you simplify it? Now since there is cot here and this is tan inverse x, you can change tan inverse x into cot inverse, isn't it? Because tan and cot are opposite functions, isn't it? That is, you can write tan inverse x is equal to, how much is it? It is cot inverse 1 upon x. You know this formula. That is, tan inverse x is equal to cot inverse 1 upon x. Now in this case, instead of tan inverse x, you should put cot inverse 1 upon x is equal to sine cosec inverse cot within bracket. What do we write here? Cot inverse 1 upon x. Is that clear? Now, what is cot inverse 1 upon x? It is only 1 upon x. So which is equal to sine cosec inverse, you can write 1 by x, because you know that if there is cot inverse 1 by x, this cot inverse will be cancelled and you should write 1 upon x. Is that clear? So next, again this cosec inverse x. Cosec inverse x is equal to, you can convert this cosec inverse into sine inverse. In this case also sine and cosec are inverse functions, isn't it? That is, cosec inverse x is equal to sine inverse 1 upon x. Okay. Now in this case, sine, what is cosec inverse 1 upon x in terms of sine inverse? It will be upside down. 1 by x upside down is x only, isn't it? So sine inverse x, which is equal to, what is sine inverse x? It is x, which is equal to right hand side. You have understood now? So you can copy it. We'll do the next question now. Now we will do question number 24. This is also proof that sine cot inverse cos of within bracket tan inverse x is equal to, you have to prove square root, within whole square root there is a fraction x square plus 1 divided by x square plus 2, and here x is greater than 0, x is always positive. Okay, so let us write down left hand side is equal to sine cot inverse cos within bracket tan inverse x. So let us simplify it. Now within cos को भित्र एउटा inverse circular function छ, that is tan inverse x. Within cos there is an inverse circular function which is tan inverse x. Okay, so let us assume this tan inverse x has theta. So this is important question, you can mark it, right? So let tan inverse x is equal to theta. That means when this tan inverse goes to the right hand side, it becomes tan theta, isn't it? So, or this is tan theta is equal to x. Is that clear? So now, if you assume tan inverse x as theta, this expression becomes cos theta, isn't it? Now this is your cos theta. That means LHS now becomes sine cot inverse cos theta. Is that clear? Now from tan theta is equal to x, from this value of tan theta you have to get the value of cos theta in terms of x. Is that clear? Now, since tan theta is equal to x, so let us find out the value for cos theta from tan theta. So from tan theta you can get the value for sec theta, because you know that tan square theta is equal to sec square theta minus 1, isn't it? You know this formula. Sec square theta is equal to 1 plus tan square theta. You did in class 10, isn't it? Sec square theta is equal to 1 plus tan square theta. Or what is the value for tan square theta now? So tan square theta is equal to sec square theta minus 1. Right? So let us square both the sides. Or you may, let us square both the sides here. Or you may write tan theta is root over sec square theta minus 1. That is tan theta is equal to root over sec square theta minus 1 also you can write it. Okay? So let us squaring both the sides. What do we get? Tan square theta is equal to x square, or what was the formula for tan square theta? Sec square theta minus 1, right? So it is sec square theta minus 1 is equal to x square, right? So now, what will you do in the next step? Get the value of sec square theta. Minus 1 is taken to the right hand side. So, or this is sec square theta is equal to, this is your 1 plus x square. Is that clear? Now, what is the value for sec theta? What is sec theta is equal to? This is root over 1 plus x square. Okay? So what is sec theta in terms of cos theta? What is the formula for sec theta in terms of cos theta? It is 1 by cos theta. This is inverse of cos theta, isn't it? Sec theta is inverse of cos theta. That is 1 by cos theta is equal to root over 1 plus x square. Now invert both the sides. So inverting both the sides, what do we get? We get cos theta is equal to 1 upon root over 1 plus x square. Is that clear? You have understood? That is, what is the value of cos theta? We are inverting both the sides here. That is, cos theta is equal to 1 upon root over 1 plus x square. Is that clear? Now let us write it on the left hand side. So LHS is equal to, what was LHS? Sine cot inverse. Sine cot inverse cos theta is there, isn't it? Cos theta. That is your left hand side. So what will you write for cos theta? It is 1 upon root under 1 plus x square. Take sir. So is equal to sine cot inverse 1 upon root over 1 plus x square. Is that clear? So instead of cos theta, we write here 1 upon root over 1 plus x square. Is it clear to all of you? So now again you have to simplify it further. Now it is cot inverse 1 upon root over 1 plus x square. Let us assume it. Let cot inverse 1 upon root over 1 plus x square is equal to beta. Suppose it is beta, right? Now again cot inverse, take it to the right hand side, it becomes cot. So you will get the value for cot beta is equal to 1 upon root over 1 plus x square, right? So now, therefore, now LHS becomes, now what does LHS become now? Sine, what is cot inverse 1 upon root over 1 plus x square? It is, what is cot inverse 1 upon root over 1 plus x square? It is beta. That means from this cot beta, you have to get the value for sine beta. Okay? Now since, what is cot beta here? 1 upon root over 1 plus x square. Now from cot beta, you have to get the value of sine beta. Directly, you cannot find the value for cot beta in terms of sine beta. First of all, in this case, you have to convert this cot beta into cosec beta, right? You cotec beta change cosec beta. So you should know the formula here also. Okay, the formula is cosec square beta is equal to 1 plus cot square beta. You should know it. This is also from class 10. Cosec square beta is equal to 1 plus cot square beta. Okay. So from here, what is the value for cot square beta is equal to, what is it? it is cosec square beta minus 1. That is the formula. What is cot square beta is equal to? It is cosec square beta minus 1. Okay. So now in this case, you have to square both the sides here, right? So if you square both the sides, what do we get? This is cot square beta is equal to, right hand side also is whole square, isn't it? 1 upon 1 plus x square. Is that clear? Now, or on the left hand side, you can write cot square beta in terms of cosec square beta. What is the formula? It is cosec square beta minus 1. So it is cosec square beta minus 1 is equal to, what is it? 1 upon 1 plus x square. Is that clear? So now what we will do? Minus 1 is taken to the right hand side. So or cosec square beta is equal to 1 plus. So minus 1 is taken to the right hand side. It becomes 1 plus 1. 1 upon 1 plus x square. Is that clear to all of you? So or this is your cosec square beta is equal to, what's the LCM? You can take the LCM here. What's the LCM? It is 1 plus x square. Mathi kati huncha? 1 plus x square into 1 plus x square, then write down plus 1, right? So now let us simplify it. Or cosec square beta is equal to, how much is that? It is x square plus 2 divided by x square plus 1, right? But you have to get the value for left hand side is equal to sin beta. You have to get the value for sin beta. Let us convert into sin beta form. You have to prove this result. Okay. Now next step from here. What is cosec square beta? 1 by sin square beta is equal to x square plus 2 divided by x square plus 1. Is that clear now? So next, what will you do? From here you can get the value of sin square beta by inverting both the sides. So if you invert both the sides, what do we get? That is sin square beta, left hand side is inverted. You have to invert the right hand side as well. So right hand side invert garda x square plus 1 divided by x square plus 2. Okay. Next, what is the value for sin beta? So sin beta is equal to, within square root, x square plus 1 divided by x square plus 2. Is that clear? Now you have to write down the left hand side. So LHS is equal to, in the previous steps, you can check that the simplified form of left hand side was sin beta only. Isn't it? It is sin beta. You can check it in the previous steps. You can check it in your copy. In the previous steps, there was sin beta. Left hand side was simplified as sin beta. Now what is the value for sin beta? It is this one. So root over x square plus 1 divided by x square plus 2, which is equal to this right hand side. So it is proved. So understood? So I think you have understood it. So you can copy it. We'll do the next one. So now we will do the next question, that is question number 25. Now we have to simplify it. You have to simplify it, okay? And you have to find out the simplified value of this expression, right? So now here you can use the formula sin inverse 2x upon 1 plus x square, cos inverse 1 minus y square upon 1 plus y square. You may directly use the formula, or you may use method of trigonometric substitution here. What should you put for x here, so that we can have this form sin inverse sin 2 theta? What can you substitute for y here, so that we can have the form of cos inverse cos theta form? Okay, so let us assume, so in this case, if there is sin inverse 2x upon 1 plus x square, we can put x is equal to tan theta. we can put, let x is equal to, we can put tan A also, tan theta, or we can put x is equal to tan A, and y is equal to, you cannot put here tan A again because these x and y are two different variables. If x is taken as tan A, you should take y as tan B. So it is tan B. Okay. So let us find out the value for A here. What is A is equal to? It is tan inverse x. And what is the value for B here? It is tan inverse y. So we may or may not use the value of, capital A and capital B. Or we may use tan A and tan B. That is as x and y respectively. Okay. So let us simplify now. So now, which is equal to? Now this expression becomes tan within third bracket half sine inverse. What is x here? We had assumed x as tan A, 2 tan A divided by 1 plus tan square A. Let us put it within first bracket, right? So this is your sine inverse, right? This is your sine to the power minus 1. But you cannot read it as sine to the power minus 1. It is read as sine inverse, okay? This is read as sine inverse. Is that clear? Next one is plus half cos inverse within bracket 1 minus. So what is y in this case? It is 1 minus, what is y square? Tan square b divided by 1 plus tan square b. First bracket closed, third bracket closed. So I think you have understood it. So which is equal to tan of within third bracket half sine inverse within bracket. So now can you tell me what is the formula for 2 tan A divided by 1 plus tan square A? What is the formula for 2 tan A divided by 1 plus tan square A? That is sine 2A, right? This is from multiple angles. That is sine 2A is equal to, what is the formula? 2 tan A upon 1 plus tan square A. This is the formula for multiple angles. Similarly, what is 1 minus tan square B upon 1 plus tan square B? That is your cos 2B. That is cos 2B is equal to 1 minus tan square B divided by 1 plus tan square B. Is it clear to all of you? So we will use this formula here, right? So what is 2 tan A upon 1 plus tan square A? It is sine 2A. Sine 2A, right? Plus half cos inverse. What is the formula that one? 1 minus tan square B upon 1 plus tan square B. What is it? It is cos 2B. So it is cos 2B. Then third bracket is closed. Is it clear now? Now let us simplify it. So let us simplify it. Is equal to tan within third bracket. This is half into, what is sine inverse sine 2A? It is 2A plus, again it is half into, what is cos inverse cos 2B? This is 2B, right? So here 2 gets cancels, here also 2 gets cancels, is equal to tan inverse within bracket A plus B. Is that clear to all of you? So next, what will you do now? So this is your tan inverse A plus B. Oh sorry, not tan inverse. It should be tan only. This is not tan inverse, it is tan of A plus B. Okay? It is not tan inverse, but it is only tan. So it is tan of A plus B. Okay? Now this is the formula from compound angle. You know in trigonometry compound angle. So from compound angle you can write down the formula of tan of A plus B. You have done it in class 11. What is tan of A plus B? This is tan A plus tan B divided by 1 minus, this is tan A tan B. Okay. Now in this case you have to put the value for tan A and tan B, but not the value for A and B. Okay. यसमा चाहिँ हामी A र B को मात्रै भ्यालु हाल्दैनौं, तर हामी केसको भ्यालु हाल्छौं? tan A र tan B को भ्यालु हाल्छौं. अघि नै मैले भनेको थिएँ तिमीलाई, we may or may not use the value for capital A and capital B. तर हामीले यहाँ capital A र capital B को मात्रै value use गर्नु परेन. तर हामीले के value use गर्नुपर्छ? tan A र tan B. What was tan A? Tan A was x, right? And what was tan B? It was y. X plus y divided by 1 minus xy. So this is the simplified answer for the given question. Is that clear? So this is the answer. So we'll do the next question now. So now we will simplify the next problem number 26. Okay. In this case also you have to find out the simplified value of this expression, that is cos of within bracket 2 cos inverse x plus sin inverse x when x is equal to 1 upon 5. So in this case directly you cannot put the value for x is equal to 1 by 5 here. Okay. First of all you have to simplify this given expression, right? So this is your given expression. Let us simplify it. So how will you simplify it? 2 cos inverse x can be written as cos inverse x plus cos inverse x, isn't it? So let us write cos within bracket. Let us write down this first term, that is sin inverse x as the first term. Let us write sin inverse x as the first term. Now we can break these 2 cos inverse x. We can separate the term. So how can we separate it? Plus cos inverse x plus cos inverse x. Is that clear? So which is equal to cos of within bracket. Now you know this formula. We have done it. What is sin inverse x plus cos inverse x? What is the formula for sin inverse x plus cos inverse x? Now you know this. What is sin inverse x plus cos inverse x? It is pi by 2. So while doing formulae, we proved it. That is, I think it's in formula number 3. I think it's in 3. It may not be in question. It may not be in formula number 3. It may be 1, 2, 3 like that. Okay, but you should know this formula. That is sin inverse x plus cos inverse x is equal to pi by 2. Okay. So now, instead of sin inverse x plus cos inverse x, you can write pi by 2 plus. So it is cos inverse x. Is that clear? Now this is your cos 90 degree plus theta, isn't it? So this is the formula cos 90 degree plus theta. If you write pi by 2 radians in terms of degree, you will get 90 degree. What is the formula for cos 90 degree plus theta? You know that 90 degree plus theta always lies in the second quadrant. That is, cos is negative in the second quadrant. 90 degree plus theta means more than 90 degree. So 90 degree plus theta lies in the second quadrant, and in the second quadrant cos is always negative, right? And since 90 degree is 90 degree into 1, that is the odd multiple of 90. So cos changes to sine. So it is sine theta. So what is the formula here? It is sine theta. But in this case, instead of theta, there is cos inverse x. So what is the formula now? Minus sine. What is theta here? It is cos inverse x. Is that clear to all of you? Okay. Now, since there is sine here, you can change cos inverse x into sine. You know the formula of cos inverse x in terms of sine, isn't it? That is cos inverse x is equal to, what is the formula in terms of sine inverse? It is sine inverse root over 1 minus x squared. That is the formula, right? So cos inverse x is equal to, directly you can write down it as sine inverse root over 1 minus x squared, right? So it's equal to minus sine, within bracket you should write sine inverse root over 1 minus x squared. Is it clear to all of you? So I think you have understood it. Now let us simplify it. Now in the next step, what will you write? Is equal to, now this is in the form sine inverse x. If it is sine inverse x, what will you write? Only x, isn't it? But in this case it will be minus root over 1 minus x squared, right? So now we can put the value for x. The value for x is given out here. So x is equal to, what is it? Given 1 by 5, right? So let us put it minus root over 1 minus, this is your 1 upon 5 whole square, right? Now let us simplify it. Root over 1 minus 1 by 5 whole square, 25, minus root over, how much is it? 25 ones are 25 minus 1, 24 by 25, right? So there is no exact square root for 24, but you can write it as 4 into 6. So it is minus root over within square root. How will you write 24? 4 into 6 divided by 25. So what is the simplified answer now? Minus 2 root 6 divided by 5. So this is the final answer. So 24 is, 25 ones are 25, minus 1 is 24. 24 is written as 4 into 6. What is square root of 4 is 2 and square root of 25 is 5. So 6 remains same, that is 6. So what is the simplified value of cos of 2 cos inverse x plus sin inverse x when x is equal to 1 by 5? It is minus 2 root 6 whole divided by 5. So this is the simplified answer for the question number 26. Okay. So let's do question number 27 next. So next we'll do question number 27. You have to simplify it again. You have to find out the simplified value of the given expression. That is number 27. Okay. So it is given 2 tan inverse 1 plus x upon 1 minus x plus sin inverse 1 minus x square upon 1 plus x square. Okay. So let us first simplify only the first term. So let us write only the first term now. Let us simplify it. So first term is equal to 2 tan inverse within bracket 1 plus x upon 1 minus x, right? So in this case, which formula is used? Okay, so let us use this formula now. Tan inverse, you know this formula, x plus y upon 1 minus xy, I think. What is the formula? Tan inverse within bracket x plus y upon 1 minus xy. What is this formula? It is tan inverse x plus tan inverse y, right? So this is the formula, tan inverse x plus tan inverse y. You should know this formula, right? So now let us change this expression into this formula form. So is equal to 2 tan inverse, instead of x here it is 1, plus instead of y here it is x divided by 1 minus xy is there. So we can write here this in terms of x there is 1, instead of x there is 1 into instead of y there is x, 1 into x, right? So here if you compare these two, you will get here x is equal to 1 and y is equal to x, right? So that we can use this formula, that is tan inverse x plus tan inverse y. Now it is 2 within bracket, what is the formula? Tan inverse, instead of x there is 1, instead of y there is x, and instead of x here, instead of x there is 1 and instead of y there is x. So this is the form tan inverse x plus y upon 1 minus xy. Is that clear? So you can use this formula now. So this is tan inverse 1, that is tan inverse x, plus what is tan inverse y here? It is tan inverse x. Is it clear? So which is equal to, now you can multiply them, 2 tan inverse 1 plus 2 tan inverse x. Now, but in this case, you cannot simplify 2 tan inverse x, but you can simplify tan inverse 1, isn't it? If it is tan inverse 1, you can write 1 in terms of tan. So tan of which angle is 1? Tan pi by 4, isn't it? So we can write, instead of 1, tan pi by 4. So right now, which is equal to 2 tan inverse within bracket, instead of 1 you can write tan pi by 4. Okay, instead of 1 it is written tan pi by 4, because you know that tan inverse tan x is always x, plus second term remains same, it is 2 tan inverse x, which is equal to, next, 2 into, what is tan inverse tan pi by 4? It is pi by 4 plus, this is 2 tan inverse x. Here 2 ones are 2, 2 2s are 4, which is equal to pi by 2 plus 2 tan inverse x. Right? So this is your first term. So first term is simplified. That is, what is the value for 2 tan inverse 1 plus x upon 1 minus x? Its simplified form is pi by 2 plus 2 tan inverse x. Clear? Now let us simplify the second term. So now let us write the second term. So here second term is equal to, what is the second term here? Write down the second term. It is sine inverse 1 minus x square upon 1 plus x square. But here also you should do the trigonometric substitution, right? So let's do the trigonometric substitution. If we put x is equal to tan theta, so what happens? If we put x equal to tan theta, 1 minus tan square theta upon 1 plus tan square theta, that is the formula cos 2 theta. But since it is sine inverse, this cos 2 theta can be changed into sine, right? So let us put here x is equal to tan, because you know the formula. If you put x is equal to tan here, you will get 1 minus tan square theta upon 1 plus tan square theta is equal to, what is this formula? It is cos 2 theta, right? So let us put, let x is equal to tan theta. Let us get the value for theta. What is theta is equal to tan inverse x, right? So x is equal to tan theta is there. What is the value for theta? Theta is equal to tan inverse x. You know that, isn't it? So second term is equal to, sine inverse. So within bracket, what is 1 minus x square in this case? 1 minus tan square theta divided by, in the denominator what do we write? 1 plus, this is tan square theta. Is it clear? So next, which is equal to sine inverse, what is the formula for 1 minus tan square theta upon 1 plus tan square theta? Just now we have written it, 1 minus tan square theta upon 1 plus tan square theta is equal to cos 2 theta. That is the formula from multiple angles of trigonometry, right? So it is sine inverse within bracket. The formula for this expression is cos 2 theta. Now you have to change cos into sine, because this is in terms of sine inverse. If you write sine inverse sine x form, you can write x only, isn't it? So sine inverse, let us convert into sine. So it is sine within bracket pi by 2 minus 2 theta, right? Because sine 90 degree minus theta is cos theta. So sine 90 degree minus 2 theta is cos 2 theta, right? What is sine inverse sine 90 degree minus theta? It is theta. Sine inverse sine theta, when I go theta. But what is sine inverse sine of 90 degree minus 2 theta? It is 90 degree minus 2 theta. So what is the value for theta in this case? It is tan inverse x, which is equal to pi by 2 minus 2 tan inverse x. Is that clear now? So we have got the simplified value of the second term also. So now write down the given expression is, what is the given expression now? Given expression is equal to, what is the given expression? 2 tan inverse 1 plus x upon 1 minus x plus sine inverse 1 minus x square upon 1 plus x square, right? This is the given expression. Again, we will write it again, okay? Now we have to substitute the value, right? Now, what is the simplified form of the first term? We just find it, this one, isn't it? So, before this second term, there is this expression, pi by 2 plus 2 tan inverse x. But this is the simplified form of this first term, isn't it? So instead of this first term, that is 2 tan inverse 1 plus x upon 1 minus x, you write this one, that is pi by 2 plus 2 tan inverse x, right? And what is the simplified form of sine inverse 1 minus x square upon 1 plus x square? What did we get? Pi by 2 minus plus, this is pi by 2 minus 2 tan inverse x. Pi by 2 minus 2 tan inverse x. Is that clear? Now next, you can cancel these 2 tan inverse x gets cancels. So what is pi by 2 plus pi by 2? Pi by 2 plus pi by 2 is 2 pi by 2. There 2 gets cancels and you will get only pi. So this is the simplified value of the given expression, that is question number 27. That is the value of 2 tan inverse within bracket 1 plus x upon 1 minus x plus sine inverse within bracket 1 minus x square upon 1 plus x square is equal to what? It is pi. Okay. So you can copy it. We'll do the next question again. So now let's simplify question number 28. Okay, it is given tan of, you have to simplify it, tan of within bracket sine inverse x plus sine inverse y plus tan of within bracket cos inverse x plus cos inverse y. Okay, let us change this cos inverse x and cos inverse y in terms of sine inverse, or you may change sine inverse x and sine inverse y in terms of cos inverse x and cos inverse y respectively. तर हामी एउटा मात्र चेन्ज गर्छौं. तो कसरी चेन्ज गर्छौं भन्दाखेरि हामीलाई यो याद छ नि फर्मुला हैन, that is sin inverse x plus cos inverse x is equal to pi by 2, isn't it? Then sin inverse y plus cos inverse y is also what? It is also pi by 2. So let's use this formula to convert either sin inverse x, sin inverse y into cos inverse x, cos inverse y, or to change cos inverse x and cos inverse y into sin inverse x and sin inverse y. तर हामी एउटा मात्रै चेन्ज गर्छौं. Let us change this second term, that is cos inverse x and cos inverse y into sin inverse x and sin inverse y using these two formulae. Right? So now first term remains same, sin inverse x plus sin inverse y, right? Plus tan of now within bracket, what do we write? What is cos inverse x in terms of sin inverse x from here? What is the formula for cos inverse x is equal to pi by 2 minus sin inverse x, isn't it? So here you can write pi by 2 minus, this is sin inverse x, right? It is pi by 2 minus sin inverse x. Next plus, what is the formula for cos inverse y from here? It is pi by 2 minus sin inverse y. Is that clear? So I am rubbing it, this one. Now you know that. What is cos inverse y? Pi by 2 minus sin inverse y. Is that clear? What is cos inverse y in terms of sin inverse y? It is pi by 2 minus sin inverse y. Clear? So which is equal to tan within bracket, it is sin inverse x plus sin inverse y, right? Plus tan, let us write it within second bracket. Okay, so what is pi by 2 plus pi by 2? What is pi by 2 plus pi by 2? That is your 2 pi by 2. 2 gets cancelled. So what do we get? Only pi minus sin inverse x minus sin inverse y. Here minus is taken common. So within bracket, what do we get? It is sin inverse x plus sin inverse y. Is that clear? So in this case, how did we simplify it? Pi by 2 plus pi by 2 is 2 pi by 2. That is 2 gets cancels. You will get only pi. Now minus sin inverse x minus sin inverse y is there. So you take minus sign common. So within bracket, what do we get? It is sin inverse x plus sin inverse y. Is that clear? So again, first term remains same. Tan within bracket sin inverse x plus sin inverse y. Right? Plus. Now, This is in the form tan 180 degree minus theta. So what is the formula for tan 180 degree minus theta? Your pi is 180 degree. 180 degree minus theta. What is tan 180 minus theta? So let us take this sin inverse x plus sin inverse y as theta. What is the formula for tan 180 minus theta? It is minus tan theta, because 180 degree minus theta lies in the second quadrant. In the second quadrant, tan is always minus. And since this is 90 into 2, that is 180 degree is even multiple of 90. So tan remains same, that is minus tan theta. So here also, what is tan pi minus this sin inverse x plus sin inverse y? It is minus sign. So instead of plus, you should write minus. So tan remains as it is because pi is 180 degree. So it is even multiple of 90 degree. So tan remains same. That is tan of, what is the value for theta in this case? It is sin inverse x plus sin inverse y. Is it understood now? So now you have understood, right? So these two can be cancelled. So which is equal to, what is the value of this expression? That is 0. This is your answer. Okay. So the simplified form of this question is 0. Right. So you can copy it. We'll do the next question now. So now we will do question number 29. So the question is, if xy is equal to 1 plus a square, it is given. Then prove that. You have to prove that tan inverse 1 upon a plus x plus tan inverse 1 upon a plus y is equal to tan inverse 1 upon a. We have to prove this LHS is equal to RHS using xy is equal to 1 plus a square. That is your given part. Okay. So let us prove it. Let us write down LHS left hand side. So LHS is equal to tan inverse 1 upon a plus x plus tan inverse 1 upon a plus y. So which formula is used here? Tan inverse x plus tan inverse y, isn't it? 1 upon a plus x, take it as x. 1 upon a plus y, take it as y. So this is tan inverse x plus tan inverse y. So what is the formula now? Tan inverse within bracket. What is x plus y? X is 1 plus x plus what is y? 1 upon a plus y. You know the formula, isn't it? That is tan inverse within bracket x plus y divided by 1 minus xy. 1 minus what is x? 1 upon a plus x into what is y? 1 upon a plus y. Is that clear? Now let us simplify it further. So we can take the LCM is equal to tan inverse. Now let us write it within second bracket. So what's the LCM in the numerator? It is a plus x into a plus y, right? So in the numerator you will have this LCM is divided by a plus x. A plus x gets cancelled. You will get a plus y and it is multiplied by 1. That is a plus y. Plus, okay, this a plus x into a plus y is divided by a plus y. A plus y gets cancelled. You get a plus x into 1 is a plus x, right? So now in the denominator, what's the LCM? A plus x into a plus y. This is the LCM. So now below 1 there is 1. So we can multiply this a plus x into a plus y by 1. What do we get? A plus x into a plus y. Isn't it? A plus x into a plus y into 1 is a plus x into a plus y. Then minus sign is there. 1 ones are 1. Here second bracket is closed. Is that clear? Now here you can cancel. So we can cancel here this a plus x, a plus x. This LCM gets cancelled. A plus y gets cancelled. So next step, write down. Now which are the remaining terms now is equal to, it is tan inverse, now within second bracket. In the numerator there will be x plus y plus 2a. this is x plus y plus 2a whole divided by. Now we can multiply these two factors, isn't it? A into a square plus a into y. What is a into y? ay plus x into ax plus x into y, xy, then write down minus 1 is there. So we have multiplied these two factors, a plus x into a plus y. So we got this result, isn't it? A square plus ay plus ax plus xy, then minus 1, right? So next, you know the value for xy, isn't it? What is the value for xy? It is given as 1 plus a square. Xy is given as 1 plus a square. So instead of this xy, you can write 1 plus a square, right? So is equal to tan inverse. Now within second bracket, x plus y plus 2a whole divided by. Now in the denominator, a square plus ay plus ax plus. What will you write for xy? The value for xy from here, from given is 1 plus a square. So write 1 plus a square for x into y. Then write down minus 1. Second bracket is closed. So is that clear now? So here you can cancel plus 1 minus 1 gets cancelled. You can cancel them. So which is equal to tan inverse within second bracket, write on the numerator remains same. But in the denominator, first you write this ax, then you can write ay plus. Next, what is this a square plus a square? It is 2a square. So it is 2a square, second bracket is closed. Is that clear? Now in the next step, this expression becomes tan inverse within second bracket. So numerator remains same, but in the denominator, how will you simplify it? You can take a as common, isn't it? So in the numerator we have x plus y plus 2a, this whole divided by. In the denominator, what is common here? A is common, right? So a is common, within bracket what do we get? X plus y plus then twice a. One of these a is taken common here, so it is only 2a, right? First bracket closed, second bracket closed. So here you can cancel x plus y plus 2a, which is equal to tan inverse, actually it is 1 so it is tan inverse 1 upon a. So it is proved. Okay, you have understood this one? So you can copy it. Now I will give you the homework, right? So now these are your homework, right? So you सबै तिमीहरुले homework गर्नु. So these are your homework. So question number 22 is prove that sine cos inverse tan within bracket sec inverse x is equal to within square root. It is 2 minus x square. So I think you can prove it. You prove LHS is equal to RHS. It is similar to question number 24. We did question number 24 here, isn't it? In the class, we did question number 24, and this number 22 is similar to question number 24. And these are the questions from HS, higher secondary, right? So this is from HS 2015. Number 1, A2 is, you have to find out the value of tan inverse 2 cos 2 sin inverse half, first bracket close, second bracket close. Consider only the principal values here, okay? So here, भित्रबाट simplify गर्दा नि half. Sine of which angle is half? Sine pi by 6. भित्रबाट तिमीले simplify गर्दा नि मिलिहाल्छ. You can do it, okay? Just try it once, okay? Now this is from the same year 2015, 2a number 2. You have to prove that this LHS is equal to RHS, okay? use tan inverse x plus tan inverse y formula, simplify it, you will get the result. Okay. And this is from HS 2016, this one. 1A number 2, evaluate. Evaluate means you have to find out the value of 4 within bracket 2 tan inverse 1/3 plus tan inverse 1/7. So in this case, you have to simplify it. So first term here is 2 tan inverse x form, convert it to tan inverse 2x upon 1 minus x square. Use that formula to convert it to tan inverse. Then again simplify it. Then use the formula of tan inverse x plus tan inverse y to evaluate or to find out the value of this expression. Okay. And next, this is from HS 2019. You have to solve it. Solve means you have to get the value for x. Okay. So since this is 2 sin inverse x is equal to cos inverse x, you can convert this 2 sin inverse x in terms of cos inverse, isn't it? You know the formula of 2 sin inverse x in terms of cos inverse, I think. The formula here, the formula you should use here is, what is the formula you can use here? 2 sin inverse x is equal to cos inverse, what is that formula? 2 sin inverse x is equal to cos inverse 1 minus 2x square. You should use this formula. Because since this cos inverse x, this right hand side is in terms of cos inverse x, you should convert this 2 sin inverse x in terms of cos inverse, which is equal to 2 sin inverse x is equal to cos inverse within bracket 1 minus 2x square. Is that clear to all of you? So you can do it at home. Okay. So revise all the problems we did today. Okay. So this much is for today. So we'll do more problems in the next class. Right.